Every 90 minutes, the deck resets. 20 jets land, refuel, rearm, launch again, all on 4.5 acres moving through the ocean. That tempo doesn't happen by accident. It happens because 9 jobs never stop. The air boss runs the sky. The shooter sends jets into it. Green shirts catch them. Purple shirts fuel them. Red shirts arm them. And deep below, reactor crews power the whole machine. This is the loop nobody tells you about. We're taking you inside. A Nimitz-class carrier is home to over 5,000 people. The flight deck alone could park 100 cars. But it's not a parking lot. It's a factory floor, a runway, a weapons depot, and a gas station. All at once, all in motion, all while the ship cuts through open ocean at 30 knots. Day and night, the cycle runs. Jets slam aboard, taxi forward, fold wings, drop below to the hangar, or stay topside for the next launch. The clock doesn't stop, the ocean doesn't care, and the mission demands more sorties. So who keeps it running? 9 teams, 9 colors, 9 jobs that lock together like gears in a watch. Miss one step and the whole rhythm breaks. We're about to show you every gear. First, understand the colors. On a carrier deck, your shirt tells everyone what you do and what you're allowed to touch. Yellow shirts direct aircraft. They're the traffic cops. Hand signals only. No radios in the jet blast. A yellow shirt tells a 30-ton Super Hornet where to go, and it goes. Blue shirts are the muscle. They chain down aircraft, pull chocks, push, tug, and manhandle jets into tight spots. They're called handlers for a reason. Green shirts own the launch and recovery gear, catapults, arresting cables. If it stops a jet or throws one into the sky, green shirts maintain it and operate it. Purple shirts are fuel's crew. They're called grapes. They test JP5 jet fuel for contamination. They pump thousands of gallons every hour. A single mistake can ground the air wing. Red shirts handle ordnance, bombs, missiles, guns. They build weapons below deck and bring them topside. They install them on jets. They pull safety pins just before launch. One error ends lives. Brown shirts are plane captains. Each jet has one. They know that aircraft better than anyone. They do the pre-flight walk-around. They're the last set of eyes before the pilot climbs in. White shirts are scattered across the deck. Safety observers, medical, quality assurance, landing signal officers. They watch for the mistakes nobody else sees. Then there's the people you don't see. The air boss and mini boss sit in Pryfly, a small tower on the island. They control the airspace within 5 miles of the ship. They own the deck. If they say stop, everything stops. Below them, deep inside the island, sits CAT-CC, Carrier Air Traffic Control Center. The AC rating air traffic controllers run the radar picture. They talk jets onto the ship in weather so bad you can't see the deck until you're 200 feet above it. And deeper still, below the waterline, reactor operators run 2 nuclear reactors. Those reactors make steam. That steam turns turbines. Those turbines generate electricity and propel the ship. On the new Ford-class carriers, those reactors also feed the Electromagnetic Aircraft Launch System, EMALS, and the Advanced Arresting Gear. Everything on the boat runs because the reactor crew keeps the heart beating. Now watch the rhythm. A recovery cycle begins. 10 to 20 jets are inbound. CAT-CC sequences them into a holding pattern called the Marshall Stack. Each aircraft waits at a different altitude. When it's time, CATCC clears them for approach. The air boss in Pryfly monitors deck status. Are the wires ready? Is the deck clear? Is the landing area foul? If yes, he waves off the jet. If no, the landing signal officers, LSOs, guide it aboard. The jet hits the deck at 150 miles per hour. Its tail hook snags an arresting wire. The wire stretches. The jet stops in 2 seconds. Green shirts check the wire for damage. Blue and yellow shirts taxi the jet forward and clear the landing area for the next recovery. 18 seconds later, another jet slams aboard. Once all jets are aboard, the tempo shifts. Now it's about the turn. Refuel, rearm, inspect. Fix what broke. Prep for the next launch. Purple shirts drag fuel hoses across the deck. They plug into jets and pump JP5. They watch for leaks. They sample fuel from every load. Water or debris in the fuel means a flameout at the worst possible time. Red shirts roll out bombs and missiles on yellow gear carts. They mount them to pylons under the wings and fuselage. They arm fuses. They verify settings. They pull all the safety pins and hand them to the pilot in a red-tagged bundle. Brown shirt plane captains inspect their jets. They check tires, hydraulics, panels. They look for fluid leaks, cracks, loose fasteners. If something's wrong, maintainers in the hangar bay swarm it. The clock is ticking. Meanwhile, green shirts prepare the catapults. Each catapult uses either steam pressure on Nimitz class or electromagnetic force on Ford class to accelerate a jet from 0 to 165 miles per hour in 2 seconds. The cat crew inspects the shuttle, the holdback bar, the launch valves. Everything has to be perfect. When the jets are fueled, armed, and checked, the yellow shirts taxi them to the catapults. The shooter, a catapult officer, takes over. The shooter confirms weight with the pilot, confirms wind over the deck, confirms the cat is set to the right pressure or energy level. The pilot runs the engine to full power. The shooter checks for leaks, for control surface movement, for any sign of a problem. Then the shooter drops to one knee, points forward, and touches the deck. That's the signal. The cat fires. The jet leaps off the bow and climbs. 90 seconds later, the next jet launches. Then the next. Then the next, until the entire package is airborne. Then the cycle resets, and it starts again. Let's go deeper on the people who move the iron. ABH stands for Aviation Boatswain's Mate Handling. That's the official rating for yellow and blue shirts. Their job is choreography. Picture 40 aircraft on a deck the size of 3 football fields. Some are landing, some are launching, some are broken, some are being fueled, some are being armed. Every one of them weighs tens of thousands of pounds, and the deck is pitching in a storm. Yellow shirts are the directors. They stand in front of a jet and use hand signals to tell the pilot where to go. Turn left, turn right, stop, fold wings, spread wings, shut down. The pilot can barely see over the nose. The director is the pilot's eyes. One wrong signal and a jet rolls into another jet, a person, or off the side of the ship. Blue shirts are handlers. They install tie-down chains so jets don't slide across the deck in rough seas. They install chocks so wheels don't roll. They push and pull jets by hand when there's no tow tractor. It's brutal physical work in all weather. Freezing rain, desert heat, storms. It never stops. And then there's crash and salvage, also blue shirts. Their job is to respond when something goes wrong. A jet crashes on the deck. A fire breaks out. Fuel spills. Ordnance cooks off. The crash crew wears silver fireproof suits. They carry foam and water hoses. They train to drag a pilot out of a burning jet in under 60 seconds, because if the fire spreads, the entire flight deck can become unusable. And a carrier without a flight deck is just a very expensive, very slow boat. Now the green shirts. AB rating. Aviation Boatswain's Mate, launch and recovery equipment. They own the catapults and the arresting gear. That's the most violent machinery on the ship. Each arresting wire is a steel cable 1.5 inches thick. It's stretched across the deck and connected to hydraulic dampers below. When a tailhook snags it, the wire absorbs the kinetic energy of a 30-ton jet traveling at 150 miles per hour. The wire can only take so many hits before it weakens. Green shirts inspect it after every trap. They measure for stretch. They look for fraying. They swap it out on a strict schedule. If a wire snaps under tension, it can cut a person in half. The catapults are even more complex. On a Nimitz-class carrier, steam from the reactors pressurizes huge cylinders below the deck. A shuttle rides in a slot in the deck. The shuttle connects to the jet's nose gear with a launch bar. When the cat fires, steam drives pistons that yank the shuttle forward. The jet accelerates down the deck and into the air. On the new Ford-class carriers, EMALS replaces steam with electromagnets. Linear induction motors pull the shuttle. Software adjusts the launch energy for each jet's weight. A light drone needs less energy than a heavy strike fighter loaded with bombs. EMALS is smoother, more precise, and easier to maintain, but it demands massive electrical power. The reactors have to feed it. Green shirts prep every catapult before every launch. They check the holdback bar, a small metal fitting that keeps the jet in place while the engines spool up. When the cat fires, the holdback bar breaks on purpose. If it doesn't break, the jet doesn't launch. If it breaks too soon, the jet rolls forward into the jet blast deflector. And then there's the shooter, officially a catapult officer. The shooter has final authority over the launch. The shooter walks around the jet, checks for leaks, checks that all panels are closed, checks that the crew is clear. The pilot signals ready. The shooter signals the cat crew. Then the shooter kneels, points down the deck, touches the flight deck with 2 fingers, and salutes. The cat fires. It's a ballet. It's dangerous, and it happens dozens of times a day. One mistake, one missed inspection, one miscommunication, and people die, so they don't make mistakes. Now let's talk about the people who make the next sortie possible. Purple shirts, a BF rating, aviation boatswain's mate, fuels. Everyone calls them grapes. Their job is to keep JP5 jet fuel clean, tested, and flowing. A carrier holds millions of gallons of fuel. It's stored in tanks deep in the ship. Pumps push it through miles of pipes to refueling stations on the flight deck and in the hangar bay. Every gallon has to be pure. Water in the fuel causes engine flameout. Debris clogs fuel nozzles. Contamination grounds jets. So grapes test constantly. They pull samples from every fuel load. They check for water. They check for particulates. They run the fuel through filters. If a sample fails, they trace it back, isolate the bad batch, and purge the system. On the flight deck, grapes run hot pit refueling. That means refueling a jet while the engine is still running. The pilot stays in the cockpit, the rotor blades are spinning. The jet is ready to launch again in minutes. It's fast, it's efficient, and it's incredibly dangerous. One spark near an open fuel port and the whole jet goes up in flames. Grapes wear purple. They move fast. They plug the hose. They monitor the flow. They watch for leaks. They signal the pilot when the tanks are full. Then they disconnect, clear the jet, and move to the next one. Over and over. All day, all night. No fuel, no flight. It's that simple. Now the red shirts. AO rating. Aviation Ordnance Man. They handle every bomb, missile, and round of ammunition on the ship. Ordnance starts below deck in the magazines. Weapons are stored in climate-controlled compartments. AOs build them there. They attach fins to bombs. They install guidance kits. They load fuses. They test circuits. Every weapon is assembled by hand according to strict procedures. One mistake and the weapon doesn't work. Or worse, it works at the wrong time. Once a weapon is ready, AOs move it to a weapons elevator. The elevator lifts it to the flight deck. Red shirts roll it out on a yellow gear cart. They push it across the non-skid to the jet. They hoist it onto a pylon under the wing or fuselage. They connect it to the aircraft's weapon system. They verify electrical continuity. They arm the fuse. Then they pull the safety pins. Those pins keep the weapon from activating accidentally. The pins come out just before launch. AOs hand the bundle of red-tagged pins to the pilot. The pilot checks the tags. If a pin is missing, the launch stops until they find it. Red shirts work in extreme conditions. Bombs in the sun get hot. Missiles are heavy. The deck is slippery. The ship is moving. And every weapon they touch is designed to explode. They do it anyway. Because without ordnance, a fighter jet is just an expensive taxi. And then there's the brown shirts, plane captains. They're usually junior enlisted maintainers from the jet's squadron. Each plane captain is assigned to one specific aircraft. That jet is theirs. They know every panel, every system, every quirk. Before every flight, the plane captain does a walk-around inspection. They check the tires for cuts and proper inflation. They check the landing gear for leaks. They check the engine intakes for foreign object debris. They check every external panel to make sure it's closed and latched. They check the flight control surfaces, ailerons, rudder, elevators. They look for hydraulic leaks, fuel leaks, oil leaks. If something is wrong, they call a maintainer. If it's a quick fix, they do it on the spot. If it's complex, the jet gets pulled from the launch and another one takes its place. The plane captain straps the pilot in, connects the communication cord, hands over the red tag safety pins. Then the plane captain stands in front of the jet and signals the pilot to start engines. Once the engines are running, the plane captain does a final visual check, looks for leaks, looks for loose panels vibrating in the jet blast, looks for anything that wasn't there a minute ago. Then the plane captain salutes the pilot. The pilot returns the salute, and the plane captain steps aside. That salute is a promise. The jet is ready. The mission can go. Brown shirts don't get a lot of glory, but they're the last line of defense between a good jet and a bad one. They take that seriously. Fuel, weapons, inspection. These 3 jobs feed the beast, and the beast never stops eating. Now we go inside, to the people who run the machine from the shadows. Start with Pryfly. It's a small room jutting out from the island with windows overlooking the flight deck. Inside sit the air boss and the mini boss. Officially, they're the aircraft handling officer and the assistant aircraft handling officer. But everyone calls them the air boss and mini. They control everything that happens on and near the flight deck. Which jets launch, which recover, when the deck is clear, when it's foul. They monitor wind speed and direction. They coordinate with the ship's bridge to make sure the carrier is pointed into the wind for launch and recovery. They talk to the LSOs, they talk to CATCC, they talk to the squadron ops officers. The air boss has absolute authority over the flight deck. If the air boss says the deck is closed, it's closed. If the air boss waves off an incoming jet, that jet goes around and tries again. The air boss sees everything: a fuel spill, a loose tie-down chain, a person walking into a danger zone. The air boss stops it before it becomes a disaster. The mini boss handles the details, tracks which jets are where, updates the status boards, radios instructions to the yellow shirts, coordinates the flow of aircraft between the flight deck and the hangar bay. It's organized chaos, and it works because the air boss and mini boss have done this thousands of times. Now drop down into the island, into CATCC, Carrier Air Traffic Control Center. It's a dark room filled with radar screens and radio consoles. A C-rating controllers sit at the scopes. They're air traffic controllers. Same job as the ones at civilian airports, but harder. CATCC manages the airspace around the carrier. They run the Marshall stack, the holding pattern where jets wait their turn to land. They sequence the jets. They monitor fuel states. They give radar vectors to guide jets onto the approach. In good weather, it's Case 1 recovery. Visual approaches. Jets can see the ship from miles away. CATCC hands them off to the LSOs for final approach. And in bad weather or at night, it's Case 3. The jets can't see the ship. They're flying on instruments. CATCC talks them down using precision radar. The controller watches the jet's altitude, heading, and speed on the scope, calls corrections, tells the pilot when to descend, when to turn, when to drop the landing gear. At night, in a storm, with pitching decks and low clouds, Case 3 recoveries are some of the hardest flying in the world. CATCC controllers make it survivable. And all of this, every watt of electricity, every pound of steam, every system on the ship runs because of the reactor. Deep below the waterline sit 2 nuclear reactors. On a Nimitz-class carrier, they're Westinghouse A4W reactors. On the new Ford-class, they're Bechtel A1B reactors. The A1Bs generate 3 times the electrical power of the A4Ws. Why? Because Ford-class carriers replaced steam catapults with EMALS. They replaced hydraulic arresting gear with electromagnetic advanced arresting gear. Both systems run on electricity, massive amounts of it. The reactors feed them. Reactor operators don't see the flight deck. They don't see the sky. They work in shifts, monitoring temperature, pressure, flow rates, radiation levels. They control the reactor's power output. They manage the steam plant. They maintain the propulsion turbines and electrical generators. If the reactor stops, the ship stops. The catapults stop. The lights go out. The mission ends. So the reactor never stops. The crew makes sure of it. Pryfly gives the orders. CATCC guides the jets home. The reactor powers the whole fight. These are the brains and the heart, and they never sleep. So now you've seen the loop. A jet lands. Green shirts catch it with a wire. Yellow and blue shirts taxi it clear. Brown shirts inspect it. Purple shirts fuel it. Red shirts arm it. The shooter checks it. The catapult launches it. Pryfly controls the deck. CATCC manages the sky. The reactor powers everything. 90 minutes later, it happens again, and again, and again, all day, all night, in calm seas and in storms, in peace and in war. It works because 9 jobs lock together. Each one depends on the others. A yellow shirt can't taxi a jet if the green shirts haven't cleared the wire. A red shirt can't arm a jet if the purple shirts haven't fueled it. The shooter can't launch if the reactor isn't feeding the catapult. Miss one step and the rhythm breaks. The sortie rate drops. The mission slows. The floating city stops floating steel into the sky, but they don't miss. Because the people wearing those colors know what's at stake. The air boss in Pryfly hasn't seen his family in 6 months. The green shirt ABE on the catapult crew works 16-hour days in 120-degree heat. The purple shirt grape testing fuel samples does it in a cramped compartment below deck with no windows. The red shirt AO building bombs knows one mistake ends lives. The brown shirt plane captain hasn't slept more than 4 hours straight in weeks. The CATCC controller talking jets aboard at night is 22 years old and holds lives in his voice. The reactor operator will spend this entire deployment below the waterline, never seeing the sun. They do it anyway, because a carrier isn't just a ship, it's a promise. A promise that American power can arrive anywhere on Earth within days. A promise that our pilots will come home. A promise that when the world is burning, we can respond. That promise doesn't keep itself. People keep it. 9 jobs, 9 colors, 1 mission, and they do it all day. Every day. If you believe this work matters, stand with the people who do it. Subscribe to the Navy Intel to keep this community strong. 1 click tells the algorithm you back the crews in yellow, green, purple, red, and brown. It costs you nothing, but it helps this mission-focused channel reach more people who care. Hit subscribe, and in the comments, tell us which color shirt surprised you most. We read everyone, and if you've served or someone you love has, thank you. We see you. That's the loop. That's the rhythm. That's what makes a floating city launch warplanes all day. Now you know.